So, how do you build a pipeline almost 10,000 feet below the surface of the ocean? We're talking about a place where the pressure would instantly crush a submarine. An environment even more hostile than outer space. What kind of ship can even operate in these crushing depths, laying down the steel arteries that power our world? Mile after painstaking mile. Well, this isn't science fiction. It's the world of deep-sea construction, a field of engineering so staggering. It's hard to believe we're talking about floating factories. Some of the largest machines ever built working in conditions most of us can barely imagine. They're piecing together a hidden global network of pipelines that bring oil and gas from deep-sea reservoirs right to our shores. So get ready to rethink what you know about construction. We're going thousands of feet beneath the waves to see, step by step, how these giant ships pull off the impossible. Laying a pipe at 9,843 feet, that's 3,000 meters down, is one of the most extreme challenges on Earth. Down there, the darkness is absolute, and the weight of the water above creates a crushing pressure of over 4,400 pounds per square inch. At that pressure, even the tiniest flaw would cause the pipeline to buckle and implode catastrophically. The steel itself has to be tough enough to handle those forces, but also flexible enough to be installed in the first place. But the pressure is just the start. The seabed isn't some flat, sandy desert. It's a rugged, dynamic landscape, full of underwater mountains, steep cliffs, and unstable slopes that can trigger massive landslides. Before a single pipe is laid, the entire route has to be meticulously surveyed and prepared. This is where remotely operated vehicles, or rovers, come in. They're the eyes and hands of the engineers on the surface. These underwater robots tethered to the ship scour the seafloor, moving boulders, digging trenches, and even building support structures to give the pipeline a stable path. And then you have to deal with the world-famous the waves. A pipelay vessel can't just call it a day because of a storm. Once the process starts, the ship and the thousands of feet of suspended pipeline become one single connected system. If you stop for too long, you risk putting unbearable stress on the pipe, which could cause it to snap and send millions of dollars of equipment plunging into the abyss. These ships have to hold their position with pinpoint accuracy, day and night, good weather or bad, for weeks or even months. It is a non-stop, high-stakes operation with absolutely no room for error. So, what kind of machine can possibly conquer such a hostile place? Meet the fleet of highly specialized pipelay vessels, some of the largest and most complex ships ever built. These aren't just ships, they're massive. Mobile industrial platforms that can house hundreds of crew and operate on their own for months at a time. Take the pioneering Spirit V, at 382 meters long and 124 meters wide. It's the largest construction vessel on the planet. This twin-hulled behemoth doesn't just lay massive pipelines, it can lift entire 48,000-ton oil platforms clean out of the water. Then you've got the Facilitaire Fair, a 397-meter-low NG ship that has laid over 13,000 kilometers of pipeline in its career, and once set a world record by laying pipe in nearly 2,800 meters of water. Vessels like the Facilitaire constellation, purpose built for the challenges of ultra-deep water. It's got a huge tower for assembling pipe and an incredibly sophisticated dynamic positioning system. This DP system uses GPS satellites and powerful multi-directional thrusters to automatically fight against wind, waves, and currents, holding the massive vessel perfectly in place without ever dropping an anchor. On board these floating factories, you'll find everything you need for the job. There are huge storage decks holding thousands of individual 12-meter pipe sections. There are fully automated welding factories that run 24/7. Advanced inspection stations use ultrasonic testing to make sure every single weld is perfect, and coating stations protect the steel from corrosive salt water. It's basically a city at sea devoted to one single monumental task: to get the pipeline from the ship to the seabed, nearly 10,000 feet below. Engineers have two main tricks up their sleeves: the sleigh and J-lay methods. The names are pretty straightforward. They describe the shape the pipe makes as it goes from the ship into the water. The sleigh method is the industry's workhorse. It's fast and perfect for shallow to moderately deep waters. On an S-lay vessel, pipe joints are welded together horizontally on a long assembly line. As the ship moves forward, This continuous steel pipe is fed off the back over a curved support structure called a stinger. The pipe bends over the stinger to create the top curve of the ease, then slopes down through the water before straightening out on the seabed to form the bottom of the ease. Powerful tensioners, which look like giant caterpillar tracks, grip the pipe to control its descent and keep it from buckling. Ships like the Facelite FA are masters of lay and can lay over 9 kilometers of pipe in a single day. The only problem, the deeper you go, the more stress that shape puts on the pipe. That's where the J-lay method shines. For ultra-deepwater projects, J-lay is often the only way to go. Instead of a horizontal assembly line, a J-lay vessel has a tall vertical tower. Inside pipe joints are welded together into long stalks, sometimes up to 72 meters long. This stalk is then lifted, lined up, and welded vertically onto the main pipeline. The whole thing then descends almost straight down, making just one gentle curve near the seabed to form a J shape. That single bend dramatically reduces stress, making it perfect for the crushing pressures of the deep. It's a bit slower than slay, but it's the key to conquering extreme depths. There are also reel lay and flex lay methods. With reel lay, the pipeline is welded on shore and spooled onto a giant reel on the ship, then simply unspooled at sea. It's super fast for smaller pipes. Flex lay, as the name suggests, is for deploying specialized flexible pipelines from large carousels. So, how does it all come together? The whole process is a marvel of logistics and precision. Step 1, it all starts with prep. Long before the pipe-lay vessel even shows up, the work is underway. Steel pipes are manufactured and coated on land, often with anti-corrosion layers and a thick concrete shell for extra weight and protection. At the same time, survey ships are creating a high-resolution 3D map of the seabed. Then, the ROVs are sent down to clear the path of any obstacles and prepare a stable foundation for the pipeline. Phase step 2. The floating assembly line kicks in. Asterisk supply ships run a constant ferry of 12-meter pipe sections out to the main vessel. On board, the pipes enter the assembly line. For slay, they move horizontally. For J-lay, they're lifted into the vertical tower. Robotic arms handle the welding. Each joint is scanned with ultrasonic probes to find any hidden flaws, and a fresh corrosion-resistant coat is applied to the weld. This happens over and over, creating one single unbroken string of steel. Phase step 3. The controlled descent. Asterisk as the vessel inches forward on its dynamic positioning thrusters. The finished pipeline is carefully fed into the ocean. Those massive tensioners manage a load that can be hundreds of tons, making sure the pipe enters the water at the perfect angle and speed. On an S-lay ship, the stinger supports the pipe as it starts to curve, and on a J-lay ship, it descends almost straight down from the tower. It's a delicate dance between tension, ship movement, and physics. Phase step 4. Touchdown. Asterisk, all eyes are on the touchdown point, the exact spot where the pipeline first meets the seabed. This is monitored in real time by ROVs, which fly alongside the pipe to make sure it lands exactly where it's supposed to. These ROVs are the deep-sea construction workers of the operation. They can be fitted with tools to help position the pipe, connect it to other underwater structures, and even bury it in a trench for extra protection. From mapping an alien, like seabed, to forging the final weld in a floating factory, laying a pipeline 9,843 feet under the sea is an incredible symphony of power, precision, and human ingenuity. It's an industry that works completely out of sight, in one of the most challenging places imaginable, using some of the most advanced machines ever created. These giant ships and their crews are building the invisible arteries of our modern world. Every time you turn on the heat, fill up your car, or use a product made with plastic, you are connected to this amazing unseen feat of engineering, taking place miles below the surface. It just goes to show how far we'll go to push the boundaries of what's possible, conquer the deep, and power the globe. If you were amazed by the colossal engineering behind deep-sea pipe laying, be sure to hit that like button and subscribe for more deep dives into the world's most incredible machines. Let us know in the comments what mega project you think we should uncover next. Thanks for watching.